There it is.
Here it is. Yep.
That it, gentlemen?
Go for it.
Yes, we're live. Hey, everybody, welcome aboard. It's the big 51st edition, live on a Monday morning of the weekly vlog podcast for the Santa Barbara Astronomical Unit, South Coast's longtime astronomy and telescope club. We call it the SBAU Astro Hour. I'm proud to be your host, Baron Ron Heron. It's heard live every Monday morning, 11 to noon, from our computer dens and man caves. Past programs are all available for checking it out through sbau.org, or you can watch on YouTube. Well, that's it. The only way you can actually be doing it live here. Club members invited to call other folks and get on board. Episode 51. In one more week, gentlemen, we will have done this for 52 weeks or a year. This hour, we're going to talk about our snow moon about to fill up. We'll get a message from our outreach guy about a passing asteroid. We have, I guess the moon's in Cancer to Crab, and it'll set pretty early, I guess. What's the largest structure in the universe? We'll let you know. We'll catch up on the Webb telescope. Did a selfie of itself. And astronomers have discovered a new planet around Proxima Centauri.
Uh-oh.
Yeah, with that said, let's introduce you to the gang from SBAU, our four-year president, not going anywhere because there's still a pandemic in place. Hello, Jerry Wilson.
Good morning.
How's your Valentine?
Good.
You guys are still necking at your age.
Low key today.
What is today?
It's low key Valentine's Day.
Oh, yeah, that's true. That's true. Also married to a Pat, who is our merchandise manager. Mrs. McPartland's married to our outreach coordinator, Chuck McPartland.
Good morning.
A bunch of cats who may show up. Tom Totten runs the show, and he's a genius. He is our incredible webmaster, technical wizard, with our logo behind him on the screen. We were joined early by Bruce Murdoch this morning, longtime member. Bruce is also president of the Santa Barbara Theater Organ Society. If we have time, we might even get an update from you on that, Bruce. How's Bonnie?
Bonnie's great. We had mimosa champagne on the deck this morning, along with some takeout food from Cajun Kitchen, and that was our.
You astronomical.
So I got my red shirt on, and
wow. Wish we had a tape of that. Tom Whittemore, you should
Morning.
check out at Westmont College, and he's very, very much into astronomy. And his Valentine on this 14th day of the month of February is lovely Maureen. How's she doing?
She's in Minnesota right now.
Well, she's doing probably very well. We're probably being watched by Tim Crawford. We may get a note from him or something.
actually, Ron, we have Chrissy Cook is tuned in so far in the chat.
Chrissy. Well, she gave us an upbeat report, didn't she? Last month.
Oh, yeah.
I missed this month's meeting, and I'm sorry I didn't get the notice. I don't know how I get this notice, but I don't get the one for the board meeting on Saturday. Nevertheless, what do you want to talk about? Can we go to some of Jerry's forwarded sillies, science cartoons that are funny?
Sure.
They start, for me anyway, before we had warning labels. See if I can read this with my bad eyes today. It's an Arthur Mark cartoon. And oh yeah, it's the three blind mice. You ever wondered how they got blind?
Yeah, look at the solar eclipse.
Remember most of this. One of them gave the other two. They all three took, there it is, took binoculars, and the one says to them, hey, it's just a matter of minutes. We're going to see a complete solar eclipse of the sun. Yeah, it didn't say solar, but lunar wouldn't do that to you, would it?
No.
But a solar would, and that's how they become blind. Can we get ancestry? Find out the lineage of Star Wars rolling robot R2-D2. God knows he probably is akin to HAL 9.
Yeah.
But he's there he is looking at ancestry.com on the board, and according to this cartoon, he's 23% toaster. He's got some camcorder in his background. Trash can 26%. Duracell bat. I would love to make the noises, but I can't. Only Star Wars can. Can you do quickly how the early bird nearly started or did start the first interstellar war? The early bird is a robin, of course. And my wet eyes here, can not even read, but there it is. Hello, we come in peace, and they're worms. Good luck. Wearing little helmets, fresh out. I like this one, the long slide on the moon. Barry finds these on a special website. Bunch of astronauts have set up a kid's slide. Well, what are you waiting for? And the top guy says, gravity. Yep. You would probably go down slowly on the moon, I imagine.
Much slower, yes.
Yeah, it's only fixed.
I don't know. Oh, no, not this guy's got a lot to read. Do you want to call that up? If you do, I'll try to get through it. Otherwise, we could refer to two that were just mailed out by or emailed out by Jerry.
I'm not sure which one you.
Well, the zebra.
Oh, yes.
Oh, yeah.
Got defragged.
All right, you want to leave that on there, and I'll see if I can
All right.
get through this. They're sucking up a guy. Yeah, into the spaceship, UFO, or nowadays UAP, unauthorized aerial phenomena. And the guy's talking about it as he's going up, and I can't read any of it. Is my weight too much on your aircraft? What, blah, 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 blah. And they decided to drop him down, let him.
I like the first part where it says, how do you avoid pulling up dirt and leaves and stuff?
Exactly.
I think you're missing a line at the top.
Is there another line at the top there? Let's see. Oh, that's it. At the top.
This beam.
Yeah.
This beam
Oh,
only
how does this beam only lift me? Okay.
lift me? Yeah, as a void. Okay, my shoes, if they would they fly, okay. I'm sure they were wondering that in First Encounters of the what was the name of the movie that
Contact.
no, it wasn't Contact, it was Spielberg.
Close Encounters, Ron.
Close
Close
encounter.
encounter.
Fine.
Made it First Encounters. So if you want to throw on the zebra,
There's your dog.
yeah, defrag my zebra. You sent that out as the faster, more efficient, non-fragmented zebra. Not sure if it would confuse a predator or not, but the other picture he sent could start us on some local, or not local, but breaking stuff. There is one breaking local story. I'll do that while you're trying to find the half shot of Mercury that he sent us, Tom. Breaking
Okay.
local news, LCO, Las Cumbres Observatory based in Galita had
Mhm.
3 of their scientists, those guys that are really into astronomy, witness, and I guess we're involved in NASA's double asteroid redirection test, the DART.
Yeah, DART. But as
Yeah.
long as he's got the Mercury up there, Mercury is a nice sight in the very early morning sky. As Tom pointed out to us, it comes up with Mars and what was the other thing?
Venus.
Yeah. This is
That's the last one to come up of the triangle.
So it just got into the morning sky, and this is shows the phase that Mercury is in right now, with features. If you've learned them, they're all news to me. I've never studied the surface of Mercury that much. Hard to see from my place.
So what do you think, Solitudo, what is that trying to say there?
Well, I have no idea.
All alone.
They've
Yeah.
named the craters on Mercury, apparently.
And Liguria,
It means something like lonely hours, isn't it?
yeah. Yeah. And Liguria is in the north of Italy. It's where they make a lot of focaccia, which I've made.
Based on the sunshine, that's on the right side of the sun. Would that be fair to say?
Yeah, it's very bright. It's very bright, Ron, coming up. And I see it about 450 here. We have a pretty good shot in the southeast.
Do
What
we
kind of
lose-
detail can you get with a big telescope from here?
Boy, that all depends on seeing. And
Yeah.
Yeah, I
Yeah.
know.
you
And
need
since
to be
it's low
high.
in the sky,
You need to be high up in on a mountain.
Yeah.
Yeah.
Somewhere like Mauna Kea.
Yeah, it never gets very far from the sun is the
Yeah.
problem.
Yeah.
So,
Andy Allen managed to image details by setting up and pre-aligning at night and getting it during the day at the time when it was at maximum elongation from the sun. And he took video and took thousands and thousands of, stills, and then
Frames.
he stacked them.
But you'll never get a picture like this from a telescope. That's taken from a probe, isn't it?
Yeah, this is a set of mosaics from a probe. There's a
Yeah.
very large crater or something way over on the left end at about 9 o'clock on the
Yeah.
left limb, and it has no name.
Well, they're
Yeah.
named. They're just not labeled here.
Yeah,
Yeah.
They're named
right.
after musicians and artists and things like
Yeah.
that.
Yeah, another interesting, Chuck, another interesting one is Heliocommunist, which would literally mean sun path. Okay.
Up top. Yeah.
Yeah, which is also the translation of Solvang. I'm sure you know that. Solvang is a Danish word meaning the sun's path.
Huh.
Okay, so
Yeah.
maybe they have like a little village there with tourists.
Yeah, it's obvious now that you
Yeah,
pointed
with
out.
with a lot of Danish, huh?
Yeah.
Yeah.
Well, and right below it is Calores Montes, which,
Yeah.
that probably means hot mountains, but it looks
Right.
like there's a lot of calories if you're eating the Danish.
And then to the left, of course, is Calores Planitia,
The plane.
Planet.
Okay.
hot planets.
Well, Elon Musk has got no plans for us to colonize that little ball, does he?
No, he's busy ruining the night sky.
Yeah.
Well, the solar outburst, whatever you call it, the CME took out, what, 40 of his 48 satellites?
Yeah,
The ones they just launched?
yeah, the solar storm caused the Earth's atmosphere, upper atmosphere to swell.
Yeah.
And so the satellites, which were in an exceptionally low parking orbit, the atmosphere swelled up and increased the drag on the satellites, causing them to deorbit.
Wow.
Breaks your heart, doesn't it?
Yeah.
Or in some cases, they knew they couldn't make their planned final orbit, so they deliberately deorbited them.
Yeah.
I see.
Well, since this is on the screen, gentlemen, did we ever have any of those LCO guys talk to our club live?
Oh,
Yeah,
yes.
lots of times.
Yeah, many times.
I think I remember one, yeah, basically, but that's the
Andy
world.
Howell.
What?
Andy Howell, right?
Yeah. At
Yeah.
least him. There were several other ones too,
Yeah.
both
For the-
Joey Chatelaine.
postdocs and pre-docs.
Joey Chatelaine talked to us about not so much DART, but the Lucy mission.
Yeah.
Oh. Tell us the Lucy mission again. I sort of forgot.
That's the one to the Trojan asteroids.
Oh, that's the Lucy. But the LCO, for the benefit of anybody watching that doesn't know, it's worldwide. They have telescopes in all the continents, don't they? Except Antarctica.
They're always
Well,
in
they
the
have them
dark.
at different longitudes, so their motto is keeping you in the dark 24 hours a day.
Yeah.
Okay.
And
but-
they have telescopes both in the northern and southern hemisphere that they hand off. They're linked together and they hand observations in mid-course to the next satellite as the Earth or the next observatory as the Earth rotates. So they can. There's no interruption for the day from an observatory.
Right.
They follow it in the whole day.
Yeah. So if they're still doing it, they had wonderful programs for kids to engage in science.
Mhm.
But Chuck, I don't know if they're still doing a lot of that.
I think they are. Galita Valley Junior High had a deal with them, and a lot of the kids there were getting to use their telescopes.
That's neat. That's really something.
Also on this DART mission, that's a binary asteroid. They just recently discovered a quadruple asteroid.
Wow.
So
Quadruple.
it has 3 moons.
All orbiting. Wow.
Yeah.
Well, isn't Proxima 3 stars?
Yes.
Okay, but
Centauri, Proxima, or yeah, the
But-
Centauri systems.
Yeah. Proxima is the closest one, but the Alpha Centauri system is triple.
Yeah.
Mhm.
okay, and so closest by how many light weeks or days or years? Are they really far apart? And that's why we just concentrate on the closest one. It's got a planet nearby, and it's a little red one, right? A little red.
Well, it's got 3 planets, they think now.
Yeah, I
And-
was leading into that.
Yeah, and it's a red dwarf.
Okay. You want to tell us, Mr. President, what they found?
Jerry?
Yeah, I'm working on it.
Oh, okay.
You pick the one at the very bottom of my list. I've got to scroll down to it.
Well, breaking news. I like to start out a newscast. This
Yeah,
is-
they found a small Earth-sized planet, but it's very close to Proxima. It's called Proxima D, and it is very close to the star, its core star. So and it has a surface temperature. It orbits every 5 days, and it probably does not have, the temperatures are not right to have liquid water on the surface. So it's probably not a host for life, although it is close.
Uh-huh.
So Jerry, it looks like the exoplanet is bigger than the star.
It's not a gas giant, it's a rocky one, 3 times.
It's a matter of perspective.
That's right. And it's an artist's drawing too.
Yes.
It would take us a while to get there anyway.
Yeah, several years.
Talking about distance, I always like pointing out to people that Voyager 1 speed, which is the fastest satellite that we have going out there so far, out away from the solar system, it's traveling like 38,000 miles an hour, and it's like 150 astronomical units away from the sun right now. That's pretty far. But 1 light year is 63,000 astronomical units.
That's
and
right.
At that speed, it'll take 15,000 years to go that 1 light year.
Yeah.
And these guys are 4 times that. So we've got a ways to go. I tell people, protect the spaceship that you're on right now. Best one you're going to have for a long time.
There's no spaceship B.
Yeah,
So anyway,
just to follow, sorry, Jerry.
Go ahead.
Just say, when I was a grad student in Arizona in the early 80s, that's 1980s, by the way. A lot of the images, the imaging team was at the U, and a lot of that stuff was coming back live. And a lot of work done by Porco and Brad Smith. It was kind of amazing to see that. I was not obviously involved in that. I was over the physics department, but it was really neat to see the stuff coming back live, and them discovering, rings around these other gas giants and things like that. It's pretty neat. Wow. Early 80s.
Okay. Well, the thing about this planet D, Proxima D, was it was discovered by measuring the wobble of the star.
Mm-hmm.
So what that means is that you look at the star with a spectrograph, look at its spectral lines, and as it comes toward you, because the planet Proxima D orbits not the star, but the star and the planet orbit in proportion the center of gravity between the two of them. So the star wobbles back and forth as the planet rotates around it. And so you can see the star move a little bit toward you and a little bit back from you as the planet pulls it back. So you look at the spectral lines in the spectrum of the star, and you can see them shift to the blue as the star moves slightly toward you, and it shifts to the red as the star moves slightly away from you. And that is an extremely sensitive way to pick up a planet. This is an Earth-sized planet and a fairly small star, so the wobble is significant in this case, enough to detect it. But they use a new spectrograph called ESPRESSO, which is an acronym, and I don't know what it stands for, but it's
a shell spectrograph for rocky exoplanets and stable spectroscopic observations.
Thank you. Thanks. And so this was the test of that new system, because it's a new, very low noise way of tracking the spectral lines shifts back and forth. And it should be quite useful now for tracking Earth mass stars. Anything down to about twice the mass of Mars will be detectable around stars. As you may know, in finding these exoplanets, the difficulty has been finding smaller Earth-sized planets. The big ones, the Jupiters and the Saturns and the super Earths, those cause significant motions and light loss when it occults. The problem has been finding Earth-sized planets around these stars. ESPRESSO is an instrument designed specifically to pick up effects due to Earth-sized planets.
I
so
remember
we're going to be hearing about that in the future.
About 15 years ago, there was a lecture at the Kavli Institute of Theoretical Physics out at UCSB, and they were talking about the planetary detections using the Doppler shift like that. And at that time, they said they could detect motions on the order of a meter per second.
Yeah.
And now it's got to be hugely more, precise
Yeah.
than that. It's amazing.
Yeah,
You got to wonder about the star bubbling and burping.
yeah.
They
Just
do, and that's part of this instrument is that it measures the bubbling and burping of the star, because the star is moving too. It's it's a plasma, so it monitors that and subtracts that from the signal.
Yeah, that's kind of technical, Jerry. I was just going to mention that when I was teaching Astro over at Westmont, we calculated the sun's wobble, okay, and whether or not from a distant, the sun's wobble is about 5 meters a second. And we were wondering if, somebody out there looking at the sun could detect the Earth, could detect, Jupiter, because that's a primary planet that causes the wobble of our sun.
Why
Well, the
did
sun wobbles about equal to its diameter.
Don't know about that. We calculate 5 meters a second.
Well, you're talking about velocity. I'm just talking about distance.
Yeah.
When
5 meters.
when we did that simulation, that's one of the things that I
Okay.
simulated.
But you can calculate this with a pencil too.
Oh yeah.
And
Oh
that-
yeah.
and that would've
Yeah.
been
Yeah.
over That would have
If
been
it's a
over
two-body
12 years.
system.
That would have been over 12 years too, because it's from Jupiter. So that's why the,
That's
Right.
correct. That's
the
right,
distance
Chuck.
and velocity sounds discrepant there.
So those
Well,
aliens have to
the
have their
sun's
scope.
the locus of the sun's orbit over time is not a simple ellipse. It goes all over the place because it's jerked on by all the planets, not just
Right.
Jupiter.
There's a number of frequencies involved in this wobble.
Yeah.
Why is it that all the attention is on the little guy, the little red dwarf Proxima? Why not the other two big ones that are closer
It's
to the
close.
I didn't
That
get
was
your answer,
distinct.
Gary.
It's not that people aren't looking at those other stars. It's just that they're not finding things there.
Yeah.
Oh, so they don't have planets, they don't think. They don't have
There was talk of one a while back. I don't know if it was confirmed or not.
But Proxima is the closest to us in
That
their
system, yes.
orbiting right now. 4.2 light years. That means the others are 4 point something else light years, probably.
Well, that 4.23 or whatever that you hear is usually to Proxima or to the center of the system.
Mhm.
Oh, there it is. Wow.
And Ron, they're only showing Alpha Centauri when there's actually an A and a B star here.
Yeah.
Mhm.
So
Well,
there's
they're
two
closer to-
stars,
Yeah.
and the red dwarf.
They say life could exist on a little planet around a red dwarf. Or is it,
No,
Well,
wouldn't-
if it's in the right place, it could.
even though it's not a lot of, it's red, the sky would be red, or at least the sun, their sun would be red, wouldn't it? Wow, look at this. I have no
They're showing
idea.
out in the future in this graph, they're showing like maybe 30,000 years from now, that's when Alpha Centauri will be the closest star to us. And look at about 3 light years. So only 3 light. Oh, look at Ross, 248 actually comes closer.
Yeah.
Mhm.
Hold your breath.
Yeah. But as close as our sun.
that'll be where the moon is in 40,000 years. No, just joking.
And that'll be messing with the Oort cloud and throwing a whole bunch of comets in.
Uh-huh.
Well, here they're showing Alpha Centauri's Neptunian planet.
Oh.
C1.
Okay, and that's on Alpha Centauri A, so that was the one I was thinking of probably.
Mm.
Oh, okay. So there's some big gas giants out there. They know for sure. Little Rockies would be in closer and be blind. We'd be blinded before we see them, I guess. But maybe the Webb that could transfer us to the Webb telescope on our way out to the full moon, gentlemen. If you're interested, anybody want to give us an update? Actually, before we go there, tell us real quickly, Chuck, what's passing by that you're going to lock in on tonight?
Oh, there's a near-Earth asteroid that's going to zoom by tonight, about a little over halfway between us and the moon, and it's going to be magnitude 12 at one point at its close approach, and moving really fast. So I'm going to try to get a video of it. Maybe I'll send it to Ruben to stick on the Facebook page.
Chuck, what was the name of that asteroid?
2022C06.
That's my phone number. What
Yeah,
is
so it's
ringing?
brand new.
Yeah.
I see. Well, magnitude 12 means we can't see it with the naked eye. You
Oh,
need a-
no way. Yeah.
But are you having to track it with your scope?
No, what I'm going to do is pre-position the scope to a star field that I know it's going to pass across, and then
does
just
it-
video it passing through.
Is it
Yeah.
a zip or does it stay in the lens long enough to watch?
Oh, it'll be there for, a minute or two.
I see.
Could be pretty windy tonight, Chuck.
Yeah, we'll see
Yeah,
how that
yeah.
goes. The seeing's supposed to be bad, but
I see.
if I'm integrating enough, I think I can still get it.
Okay.
Well, Chuck, how far away is this asteroid?
It'll be 0.58 lunar distances at the closest approach.
Okay.
Whoa, that's really close. Because they're showing one on space weather that's 0.8 lunar distances. So this
This
one's
is
closer.
CO6. It's on space weather. It's kind of a darker pink for
I
February.
got, see,
15th.
oh, on the 15th?
Well,
Oh,
it's
there it
15th
is.
UTC. It's 14th here.
Yeah.
I see. Yeah.
Well, our
Interesting.
outreach coordinator, in case you didn't know, occasionally watches stars wink out as asteroids go in front of them. That's called occulting. Have you done that lately?
Doing it tonight too, and did it a couple of nights ago.
Oh, but not with that one.
Not with that asteroid. No, it's pretty small. Also, just outreach wise, we're thinking of restarting public star parties at the museum for March 12th for the second Saturday, and also at Westmont on March 18th for the third Friday. And Tom, I'm assuming that they're still expecting us.
Which Tom?
Tom, you.
That's right. No, I haven't heard anything.
Okay, I'll poke and see what we get.
Okay.
We're
Yeah.
going to require masks for everybody who comes and for everybody who's outreaching too. So it's going to be a mask party.
March 18th will be Westmont.
Yeah, third Friday.
If that's the full moon.
So
That's okay.
Okay.
Great. And 1 week and a day before, we'll have our second online meeting, the 4th of March, with a special guest, the young PhD student down in UCLA, Lynn
Riley Lewis.
Lewis will be on our screen with a whole show after we've done our meeting. So that's the night of the 4th. Everybody's invited. I guess you'll be contacted again. Anybody want to update us on the James Webb? It's out there. It's unfolded and they're taking pictures. They did a selfie. Is that correct, Mr. President?
Yeah. Yep. We have first pictures back of the process of aligning the mirrors.
There it is.
That's the selfie of the telescope taking a picture of itself. Not a very good picture, but I guess it'll work that out. The initial alignment mosaic is in, as you can see, and they've identified now which mirror segment is producing which image. And so the first, the next step will be to get these things, which are various different shapes, to get them all to be points, and then to bring the points together into one star. And it's going to take a month or more to do that. So they're expecting science to begin in May or June. The star that they're looking at here is the one we talked about last week, HG 84406, which it turns out is just for this alignment. It's way too bright to look at in the when the telescope starts its scientific mission.
And because it's kind of isolated in the field of view.
Right.
And that way it's easier for them to figure out this pattern here, the identification mosaic.
But it's up in Ursa Major.
Yeah.
Is it something we
Do
can?
they have neutral density filters that they can slip in if they get stuff that's too bright?
No.
No.
When they slip in filters in an infrared telescope, the filter is a source of heat. And it doesn't just act as a filter. It acts as a source. So it would have to be cooled, and they're just using the cooling on the sensor itself.
On that selfie, one of those hexagonal telescope pieces was brightly lit. Is there a reason for that?
No, I don't know. I'm sure there is a reason for it.
But somehow they have a way of adjusting from behind every one of those 18
They have several sets of actuators behind each mirror.
They have 7 degrees of freedom.
Right.
$10 billion.
X, Y, Z, tilt, pan, and whatever the other one is, and then in and out.
Yeah.
So we're not going to get anything really good from it until what, June or July?
Well, that's when it will be engaged. It's starting its science mission of looking at very faint early universe items.
Does it transfer not ultraviolet, infrared, not only into visible but color? Can they put colors on distant objects using infrared only?
Well,
One,
it's all
you can take the intensity of it and
Right. You make a
assign
palette.
colors. I mean, you can do that with almost any data.
Yep.
Yeah, if they do a spectral analysis, they can assign whatever color they want to whatever frequency they're looking at.
to the human eye, infrared colors are not defined, so the palette is open to you how you want it to look.
Yeah. And Jerry, it just might be the case that with all those mirrors not quite aligned, it's probably a better telescope than we've ever looked through.
No, I would guess not, because this is looking at light that's 10 microns and beyond. So the surface, to get it quarter wave, you only have to get it to 2.5 microns.
Yeah.
We produce things to 250 nanometers.
Yeah.
And much better than that usually. Anyway, that segues into the largest structure in the universe.
There we go. All
which
right.
is
Right.
also looking back in space and time, or back in time and far in space. And the first picture shows the web structure that permeates our universe. These are clusters. The brightest things in the web are clusters of galaxies. So the bright spot in the upper left corner is, can you put that up, Tom?
Oh, sorry. Thought I had it up. Let's see.
Yeah, the bright spot in the upper left corner is a supercluster of galaxies. And these red things, the knots everywhere that you see are clusters of galaxies, not individual galaxies. And the red lines you see is hydrogen gas, dust and gas that can form stars. And then between that, you see this very open black stuff, these holes. Those are the voids, and those are largely void of hydrogen and gas and dust. And that fills the entire universe. This is not a picture. This is a computer simulation of what it looks like, assuming our current understanding of galaxy formation and evolution. It's hard to take pictures of the webbing because there's no light really to show up and make the dust and the gas stand out. The next picture with the blue fuzz is where a quasar, UM287, the big white dot in the center, is illuminating one of these filaments of hydrogen gas, extending about 1.5 million light years long into space. So if you get something that's bright enough to illuminate it, you can see parts of these webs.
Just Jerry, can I interrupt for a second?
Go, you can finish.
Go back to the previous picture. If you look at the YouTube for our speakers at the meeting that we just had, we had
Daniel
Godinez, who's a PhD student, simulating some of this formation of this web and void structure based on characterizations of the behavior of slime molds. So it's pretty interesting sort of combination of biology and astronomy.
And of course, to many people, this is reminiscent of the neural net of our brain.
Yeah.
But
I just got to mention, Jerry, that I don't know, 25 years ago, John Huckra and Margaret Geller did, something more primitive to show there was like a figure of a man in the structure. Remember that?
Mm-hmm.
The man.
No, I don't remember that, but
yeah, John Huckra and Margaret Geller boy, 25 years ago, a long time. It's just this thing just reminds me of their rendition of the universe from it basically just taking imaged galaxies from way out.
Now that, just as an aside for a moment, that reminds me of a feature that we discussed last week or the week before about the meaning. Oh, it was at the workshop, not the workshop, the members' night. My brief blurb on the members' night was the meaning of modulation transfer function.
Yeah.
You can go, it shows how much contrast you can get out of finer and finer detail. And the best you can replicate an object with an optical instrument is to have an MTF of 1. That is, you perfectly replicate what's there. The human eye system and brain is the only instrument that I know of, well, probably other animals too, but that has an MTF of greater than 1. That is, the human signal processing in your eye actually sees things that are not there. We evolved this stuff to not to get an accurate view of what the world looks like around us, but to keep us alive. And so you can, if you look through a bush and there's like a lion behind the bush, just from little flecks of motion through the leaves, you can your imagination puts it all together and gives you the shape of a lion. Many possible false positives in that system, but here we are. So the system works. So when you see a man in the network structure of the universe, that's another example of the human brain trying to find meaningful patterns in random data.
Yeah.
Our eyes also do a lot of vibration reduction. You take a 30-second exposure of something, especially if it's low on the horizon. The atmospheric turbulence makes your pinpoint stars into blobs. But you can look at them in the telescope, and even though they're moving around, your brain, puts that all together, and you see one point.
And the way we see, our eyes actually jitter at very high speed. It's not a static image. We have to have a moving image in order for the contrast to renew itself and to keep a steady image. So it's fighting against that. If you do a type of meditation, you can actually stop your eyes from vibrating. And as you do that, the visual seeing just simply goes to flat white. You lose the ability to see. But then as soon as you come out of that, your eyes start vibrating again. And especially if you have too much espresso, your eyes do a lot of vibrating.
Yeah.
So this one here, the next picture down, the blue columns, is 2 filaments that were observed of this inner universe network. These are each about 3 million light years long, taken by the Muse instruments on the Very Large Telescope. That's a radio telescope, I think, in the Atacama Desert, large millimeter, sub-millimeter array in Chile. So that's one of the longest filament images that has been obtained.
The white dots are stars in our Milky Way, but it looks beyond, right?
I don't know. Those
are probably pinpoint radio sources.
Yeah, it's definitely radio sources, but I don't know whether they're stars or quasars or what scale this is over in terms of angular field of view.
It's ET calling Ohm.
Yeah. Okay.
OMA, Ohm.
Just a little follow-up. When I was at the Lockheed Research Labs in Palo Alto, we're using a technique called dithering. I'm sure you're familiar with that.
Right.
Yeah, to bring out details in the infrared images that we're looking at.
But our local group
When
is in one of those, right? We're in a filament somehow, aren't we?
we're in one of the nodes of the filament. We're in the local group, which is a subgroup of the Virgo supercluster. So we would be in one of those white spots in where the filaments come together.
Yeah.
Right. Okay.
Up in the red picture that we first showed on this topic.
So
the slime mold view.
Yeah. So we would be up in, say, something like the white bump up in the upper left.
Yeah, Chuck, I was going to say, it reminds me of what my windshield looked like when I took a rock.
Yeah.
That's right. Yeah. But does astrophysical science think that all these things are condensing and closing in despite the Earth's or the universe expansion?
No, these things are, what you're looking at on this scale is expanding stuff. This will get bigger as the universe expands. But we're looking in this picture, and it's probably a mind blower, but we're looking at things that are a long way away, probably billions of years away.
Light years away.
And growing and probably different depths. So it probably actually doesn't in real time look like this. There's probably different depths in there. Now you can pick these out. You can tell that there's hydrogen in the way between galaxies and us. One of the reasons they're pretty well certain that these filaments exist is that since it's hydrogen, you can see the Lyman alpha absorption bands from the galaxies and quasars that are far away. As the light passes through this dust, the hydrogen absorbs some of the light out of it. And so at different distances away, at different redshifts, different spectral bands are offset from where they were a long time ago. So you can see these different offset bands for, say, the Lyman alpha line, and you get what's called the Lyman alpha forest, or the Lyman forest, which is a bunch of spectral lines all offset. And you can tell how far away that dust is by how offset the spectral line is.
But it takes a computer to draw it for us. We can't possibly see it with our cameras.
I don't know about that. I don't think that we can certainly see it to some extent with radio telescopes, as you can tell.
And you can see the galaxy clusters invisible.
Yeah.
Okay.
And here's one here, this that's up.
But the reason for my question a while ago, didn't we say in a previous program that our local group is coming together? I know Andromeda is heading our way.
It's coming together, but the next group over is moving away from our group.
Oh, okay.
It's a
all
balance
things that are gravitationally bound, Ron, that are
Right.
resisting the inflation.
So the big spider web is clotting up in balls, but spreading, all the balls are getting apart, right?
Yeah.
Roughly, yes.
Raisins in the bread.
Yeah. The raisins are shrinking and the bread is growing.
Yeah.
Been in the oven too long.
Have they explained the voids yet?
Yeah, it's the lack of anything.
Just the lack of. Just didn't happen to have any stuff there.
Why they're along veins like that, I think, is a mystery.
Well, it's part of it is how they think dark matter may have clumped early on.
Yeah.
Oh.
Yeah, we might have quantum fluctuations frozen in from the Big Bang.
What is this we're looking at?
The infrared sky.
Looks like an opal.
Yeah.
Oh, yeah.
3 degrees above zero in different areas.
Well,
Tom,
this isn't
Can you
this
explain
isn't the
it, Tom?
CMB.
It says a panoramic view of the entire near infrared sky reveals the distribution of galaxies beyond the Milky Way.
And then they've
More
labeled a
than
bunch of
one-
the clusters.
Yeah.
Yeah, but this is not a photograph. This is a data set
Yeah.
that's displayed graphically.
Well,
Well,
did that data come from visible or from radio telescopes or
No, it's near infrared.
Yeah.
near infrared? Yeah.
2 micron all sky survey. That's 2 mass.
Yeah.
Well, it can't be everything because the Milky Way itself, I'm not sure how much of the total around the sky it blocks, but it's got to be formidable, wouldn't you think?
Well, the Milky Way was superimposed on that image, Ron.
It was?
Yes.
Oh, right in the middle.
Sorry. Go back. Oops.
We can't see through the Milky Way, can we? To the other side?
Not easily, but you can. So it's between the stars, you can subtract the stars.
Huh.
You can sit in far infrared and radio. You go with it.
Totten, are we getting any comments or questions below?
No, nothing new.
Any cuss words?
Chrissy and Jim Williams are still watching, or hopefully.
Okay. I guess you lost that picture.
Yeah, I kind of lost it somewhere.
Okay.
That's the universe.
So here we can go down to interacting galaxies. This is a very nice picture of two galaxies that are in process of interacting, and you can see the streams of star-producing gas being shared by the two galaxies that are close enough to now gravitationally interact. Yeah, you can see a dark vein at the upper top, at the upper, see there's a sort of a sharp line cut off between, yeah, right where your cursor is. So there's dark gas cloud up above that, blocking some of this light. And you can see the band of star-producing dust and gas that's being peeled off of one galaxy and going up to the other one. So this is probably, my guess, is a post-collision or near miss between the two galaxies.
Jerry, this might be a tractor beam.
Yeah.
Right. But which one is the Borg?
Yeah.
So it's pretty well accepted now that an important aspect of how galaxies evolve is the way that they interact with one another. So that's how our galaxy got to be so big, is by soaking up a lot of other galaxies. We have the core remnants of other minor galaxies right around us. That's the leftover core, where it was gravitationally strong enough to retain a little bit of its identity, like the Magellanic Clouds that orbit us fairly closely. And this may be a galaxy, the blue one may be a galaxy that's about to become like the Magellanic Cloud, orbiting the larger galaxy.
Hmm.
It's got a nice barred spiral structure.
Yeah.
The top one, yeah.
Does
I was
science?
amazed at how
Go ahead.
bright were the both the large and small Magellanic Clouds when we were in the middle of Australia.
Oh,
Naked
yeah.
eye visible. Yeah.
Yeah, they
Pretty.
stand out.
Yeah.
The other one was, interestingly enough, I was in Australia, was 47 Tucanae, which is a globular cluster, but it stands out as a bright star. But when you look at it, you can tell that it's fuzzy. It's not a star.
And Omega Centauri.
Yeah. So anyway, this one, because of looking at spectral lines, you can tell which way the motion is. And this lump of material, sort of brownish material, is on its way from the large galaxy to the small galaxy. So the small galaxy might actually be very big, but in the background.
Mhm.
Well, the ordinary layman, like myself, before I joined the club, and I'm still somewhat of one, would say that why don't the stars collide? Does that happen? And is there any way to
Too far.
measure?
Way too
Too
much
far.
space.
Too far apart.
Yeah.
So they
Yeah,
never.
the main thing is space.
It's not that they never hit, Ron. It's just that the collision cross section is very, very small, so it's rare.
Mhm.
Like in globular clusters, we see these things called blue stragglers, which is where we think stars have collided and merged. But they tend to go into an orbit first, so then they have to dissipate all their angular momentum before they'll eventually merge. But it does happen.
You're talking the orbits of the galaxies or the individual stars that might get close to each other?
Well, in the case of stars hitting each other, that's kind of what you'd have to have.
Okay. So do you suppose we have binaries and trinaries out there that came from different galaxies?
Yeah.
Oh, I'm sure.
Star capture is a tricky dance to do. It's probably not that common. You need three bodies that interact the right way to get something to peel off or to join.
That's
But
why we see it. That's why we see it in crowded situations like globular clusters.
Right.
Yeah, even
And-
galactic interactions should be fairly rare because keep this in mind, the galaxies are roughly 20 times as far apart as they are large. Okay, so, I'm sure interactions go on all the time, but, galaxies are big, but they're separated by quite distances, on the average.
Well, dark matter plays a role, I'm sure, and some galaxies don't have any dark matter somehow. They found that out,
A
right?
couple of them, but only two, I think, are known that way.
Yeah.
What would be the result on them? Are they just freewheeling, free to go anywhere? They're not locked into any ground.
In that case, what you see is what you get.
Pretty good.
There you
That's
go.
very scientific, Jerry. Thanks.
Good things.
That reminds me of Tim Crawford's favorite bumper sticker, which is dark matters.
Yeah.
Yeah.
I got it on my car. Is
So
that-
on another topic, just before we close, the moon is just before full moon right now, coming up on the snow moon this month. So it turns out that in the inclined orbit of the moon around the Earth, the moon is at a high point above the sun right now and above the Earth. So when we look at the moon in this gibbous phase, we're looking up at the bottom of the moon to a slight degree. And because of that, we can see features at the very south end that we don't normally see. So it gives us a little look at features near the limb, but under the moon. And that's what this M5 Mount Clementine is. This is the region where everybody wants to build a permanent station on the moon, because mountain peaks there are always in the sunlight, so the solar power doesn't have to go through a 14-day shutdown. And in the craters there at the South Pole, some are in permanent shadow, and it's known that there is water ice there, frozen there. So you have both of those things: permanent sunlight for power and water ice for fuel and the electrolyze to produce atmosphere in your buildings.
Just
So
to
it's an
interrupt, I
interesting
just
look.
got a text actually, just before we went to this subject. I got a text from Tim Crawford saying, could we somewhere down the line, maybe in another talk, do something about lunar bases and where it'll be and how they'll be used? So that was perfect timing.
Okay, good. Take that, Tim.
Well, is this something that's always there, always lit, but we just can't see it, and it's because of where it is right now, or is it getting its first flood?
We get an unusual look, a very slight look at the south pole of the moon from the Earth, because the moon is slightly up in its, its tilted orbit. 2 weeks from now, it'll be down, and if you can see anything at all, that'll be just before new moon. You get, we will be looking at the north pole of the moon, which is not so interesting.
Yeah.
But is it fair to say that a mount like Clementine is only created by a crater? It's on the edge of the crater?
Yeah, it's probably an edge of a crater. The moon has
Okay.
been pretty well chewed up. Most everything results from some kind of crater or hit.
There
All
may
right.
be some rare volcanic features, but they tend to be small and have been beaten up.
Yeah.
But there's not a notable crater there called Clementine, just the mountain?
Well, it's probably
Uh,
part of some crater that may or may not have a name. Well, I'm sure it's named because we've mapped the entire moon, but
Yeah.
Well, are any of you gentlemen going to point your instruments at this week?
Absolutely.
All right.
Now, my backyard is still under construction, so I have no player to set it up. So this is a nice graphic up there that Tom just took down that shows how we look up at the bottom of the moon at this time. Not a big look, not a straight on look, of course, but we do get a slight angular advantage for the South Pole.
Yeah.
it's called
Yeah,
libration.
Yeah,
Right.
There's no
Yeah,
way
the
we
moon
can.
bobs up and down about
but
5.2.
there's no library involved.
Yeah.
Right.
But they think there's frozen water down there.
Oh yes, they've found it. We even smashed the spacecraft into it and watched the spray come up.
You're kidding, really?
Started a snowball fight with the moon.
Hey, Jerry, wasn't Clementine lost in a mine in full?
No, I think she fell into the water, right?
Is that what it was?
Yeah, took the footbridge across the water.
Yeah. Oh, my darling Clementine.
Yeah.
You are lost and gone
Oh,
forever. Sweet
forever.
Clementine.
No, I'm thinking of the Bobby Darin song. Sorry.
Oh,
Yeah, I was thinking of the old folk song from
oh,
the 80s.
yeah.
The one I play on
That
band.
that ice on the moon wouldn't survive anywhere else but the poles.
Right.
It'll survive anywhere where it's permanent shadow.
Yeah.
And I don't think there's any craters at the North Pole that anywhere else that meet that criteria.
But given the
I'm
fact
surprised it doesn't sublime away.
that
It's probably mixed with soil or something that suppresses its sublimation pressure.
Oh, okay.
Yeah, there's also a lot trapped in minerals on the moon.
Yeah.
oh, water's pretty heavy to take there. If they're going to set up colonies, they might want to probably be close to the poles.
That's why that's the prime spot.
Was it? I didn't know that. Just took a guess. I did not know that. Interesting.
Mhm.
What are we looking at here, Tom Totten? My God.
I'm switching around on you.
Yeah.
Artemis is NASA, isn't it?
Yes.
Colonization of Mars. Or on our way. Everything.
Well, they're starting with the moon, so that's why it's
Yeah.
called Artemis.
Yeah.
Well, you can have it. I'm not going to go along.
It's a dress rehearsal for Mars.
Yeah. You suppose Elon will go? Elon Musk?
Maybe his ashes.
Oh, we have one more topic here I forgot about. That
Uh-oh.
is the return mission from Mars.
Oh,
Yeah.
yeah.
Oh, yeah,
The sample
yeah.
return.
Uh-huh.
Yeah, this is the reason that that's here is because a contract was just let this last week to Lockheed Martin Space to build Mars Ascent Vehicle, MAV, which is a small, lightweight rocket to launch rock samples back to Earth. This shows the whole sequence of this is, you move
Sorry.
around fast, Tom.
Tom, yeah.
There, stay on that one. This is the MAV, the rocket taking off. This is a dedicated launch pad loaded with these MAVs, and and could you go to the next picture? Yeah, that one. This is a rover that's dedicated to just going around and picking up those rock sample capsules and bringing them over to that launch vehicle and loading them into the MAV, and then the MAV will take off and come back to Earth. And so that is, yeah, go ahead.
I think that MAV just goes up into Mars orbit, and then there's yet another spacecraft that'll come and pick it up.
Yeah. It's not, take the orbiting samples, go up here. It's not clear that that's going to be just shot at the Earth, or it's probably something will bring it back. Maybe one of the, actually I thought, I always thought recently that SpaceX was just going to scoop them up and mail them back to Earth, basically, on the return flight of the Starship. So, but anyway, this is the whole plan here from where over on the left from Mars 2020. The rover is up there now, and it's doing these tube collections. And then the sample fetch rover will retrieve those, and it will bring those over it'll go around Mars, picking them up, take them to the sample, or the SRL, the launch system. And then the Mars Ascent Vehicle, which the contract was just let for, will take them up to orbit, where they will be collected and then returned to Earth. It's kind of vague here. I think it hasn't been defined yet, but I'll bet you Starship brings those back.
You look at all the single point failures that are in this diagram.
Yeah.
But the whole project is called Mars Ascent Vehicle.
Yeah.
Okay. Why don't we
Yeah.
just,
Well, that rocket that takes off over here in the upper right on the diagram, that one up there, that's the Mars Ascent Vehicle, or the MAV. And that in the first picture we saw, that was the rocket that takes off.
why didn't we just assign it to United Arab Emirates? They're on Mars anyway.
They're just orbiting, Ron.
Yeah.
orbiting.
They're going to take pictures of all this. The rocket that's there has the sample in it that's going up to the right.
Oh,
Wow, what was that?
and are they being samples picked up right now?
No,
No, they're being left
samples
behind.
Yeah,
Oh, okay. They haven't done that yet.
I believe that they're still on board the rover up there.
Yeah, they may not have dropped any on the ground yet. Yeah,
Well, what's
Yes, on
perseverance?
Mars, that would be a red rover, huh, Jerry?
yeah.
All right, what's perseverance doing if it's not collecting samples? Just
It's collecting the samples in tubes, but it hasn't necessarily dropped any onto the surface at a cache yet.
Yeah.
It will be visited by this sample fetch rover.
oh, I see. So it's perseverance. So we're in the process of getting them
Yeah.
different places. Well, gentlemen, happy Valentine's Day. Hope we covered everything. We pretty much did. Thank you very much for being on board. Shall we pull the plug and go away to our respective Valentines and get ready for a Wild and Woolly program next week? Somebody's got to come up with a celebration for 1 year, because that'll be 52 weeks, gentlemen.
Mhm.
Thank you both, Toms and Bruce and
Yeah.
President Jerry, and I'll see you all on Monday. What is next? The 28th. And then 4
So
days
next
later,
Monday,
21st.
21st.
at 7:14.
All right, 2 more programs before we have our March 4th, and then the week after that, we have our big star party, assuming
Yeah.
they don't pull the plug on us.
Are you sure you have the right count, Ron? Because we didn't start these till March. So
Right.
how could we have a year's worth yet?
Yeah.
Because we're coming up on March. Well, I may have missed a week. I
Yeah.
write it every Monday. I write it in my calendar book, so I'll go back. I may have missed one. This might
Is
be.
this a leap year?
Yeah. We got to make sure we celebrate the absolute correct birthday.
Look into it. If I'm mistaken, I'll certainly rectify it, and we'll look into it together and probably have the answer by next Monday morning.
All right.
Okay.
Okay.
Take care, everybody.